All right. So you can join my presentations if you are if you want to scan the QR code, or if you are using a laptop, you can just type in menti.com and you can enter the code 87962093. Okay, so you enter the code and you will see the same screen as my presentation. Okay, so that's one way to look at the slide. Okay, all right. Let me just continue a little bit. So, of course, I think most of you already take another class with me in calculus, right? So my name is Imanadi Purnama. Uh, I'm your instructor in basic math and also calculus. I think most of you have taken my calculus class also. So we will see each other quite often. So hopefully I can remember your name. Okay. So the online class just for this week. Okay. So next week we will meet each other in the classroom. Okay. So I congratulate you for taking the uh, the Taiwan Tech. Okay. And welcome to my class. Okay. Welcome to my basic of math class and also the calculus class, at which you are. I think some of you already coming this morning, right? And since this is the we call the nighttime class, so we will have 3-hour lectures starting from around 6:25 in the schedule until around 9, right? So every week we will have this 3 hours at the night. So hopefully it's not getting you any trouble because of the night class. And also this is my first time teaching at night. Okay, so yeah, actually this is my first time teaching at night. Usually I'm teaching the latest one maybe around 5:20, 5:30. And so this is the first time I teach from 6:25 to 9. Okay. So I hope you guys also can enjoy also my class. Okay. Um, okay. Some of you still joining the chat. Let me check how many are there. Okay. Okay, 20 participants for today. Okay. By the way, have you checked your results? Okay. Your test results, your mathematics results? Have you checked? Or you know that, or whatever the result you still need to take, or whatever? Or do you guys already check, or haven't? Hmm? Have you checked your test? Okay. And how about the result? How about the result? You need to take all, at least the, okay, ITP students need to take this class. Okay. All? Really? Okay, I think that's still okay. Still okay. You can still catch up for other course as well. Okay. Okay. Okay, let me continue my slide. So first, I will tell you our my plan. Okay, my plan, schedule, and all the informations that needed. So textbook, textbook. Uh, using the James Stewart. The same with calculus, but this is for pre-calculus. Okay, so pre-calculus, 7th edition, and then calculus story. That's just for some additional, and then Wolfram Alpha. Okay, Wolfram Alpha. I forgot to mention the GeoGebra, same materials that I told you in the morning class with calculus. So let me show you Wolfram Alpha if you haven't, or if you forget what is Wolfram Alpha. Wolfram Alpha is basically computational intelligence. So it's actually like a calculator, but it can answer every topics. You can see the topics here that have that they have the algorithm to answer. So it's ranging from math, science, technology, society, culture, everyday life, and you can browse more topics if you haven't seen any topics that you want to browse. But we will just focus on this mathematics, okay? So basically, what you want to write here, aside from, you can write some equations. They have this calculators here. You can choose which equation you want to build. Okay, basically that. Or you can write, for example, let me write the integration or the derivative of, and then you may write, or maybe the roots. I'm not sure whether it's understand my question or not. Let me just write the roots of function. Let me just write whether it's understand or not. Let me just check. This is my random equations. Let me just check. Okay. It's under it is understand my question. It's finding the roots here. The graph. Okay. So yeah, I think really useful. I think it's like some how to say, like a game, right? You can write like anything if you want to know more about maybe some functions, to know whether the functions is what kind of graph it can build on, and etc. Okay, this is a Wolfram Alpha, so I believe it will be really useful. Another one is, I forgot to mention in this slide, is the GeoGebra. I think in the morning class also I mentioned this GeoGebra. So you can start to draw, okay, to draw the graph. Okay, so you can just input here any functions that you can draw on. Minus 8x, okay, like that. Or you want to use the given functions in the calculators here. Maybe writing a sine inverse x. Okay. And you can also add another functions. Let's say we have e with power of x and power of x squared, like that. So we have 3 different functions, and you can erase or hide the others if you want to focus on one functions. And also, aside from the calculator, I didn't mention about what other subject that you can browse on your GeoGebra. So in your GeoGebra, you have two options. First is the calculator, the one that we are having fun making a graphs and draw the functions, etc. Okay, The other one is this classroom resources. Okay? This is a place that you can learn on your own. Okay, so what do I mean by this classroom resource is you can look up any activity, any books, anything that's related to math or calculus. Practically, you can find out here. But to make it more narrow, you can find the topics first. Like for example, you can search here, maybe searching, parametric equation. Or let me just write parametric. Okay, maybe here you can find, and even they made up a graph like this. It's really interesting actually. It's really fun how to make this graph, and actually this is created by people that have their interest in math. So everything here, all in this GeoGebra, all the resources is free. So you can click and for example, this one, parametric equations. So we can move on here. So this is built by other people. You can build as well and then upload your works, and then you can make an activity or make a book. That's also okay. And then yeah, particularly this is just to show you how the trajectory or how the tangent for the parametric. Okay, so yeah, we haven't yet going here, but yeah, this is just for example. Let me just looking at the other, let's say trigonometry. Okay, let's say we take this. Yeah, we can play and notice that this is just to show you that we can find the area of the triangle using the sine, the law of sine. Okay. We will also learn maybe a little bit later in our basic of math. Okay. Yeah, but that's just some introduction that I want to show you. That what I expect is you cannot really rely on the topics on the class, so you need to also to digging on your own. Okay, to know more, to understand more. Okay. Okay, if you are looking for the textbook, I think, not sure whether the library has, but you can check the library if you want to check the textbook. Okay, let's go to the next slide. What do I have? Oh, scoring system. So we will just having quiz and final exam for the test, and the other one is activity. Activity will be defined by I haven't write clearly in details. So this 30% is for the attendance, participations, and the other one is I call it homework or projects. Okay? So that is what will you do for the basic of math. Okay, I will tell you later what kind of project that you are going to work on. Okay, but the most percentage is the quiz and final exam. So if you did well for the quiz, final exam, you already get around 60 to 70%. So you just need to add 5 to 15 to make it around 80. So I think these numbers, if you can have a stable score for every test, I believe you should be fine. Okay, it should be fine. However, if you did not really good, either final exam or quiz, you can still have the projects. Okay, so I hope it can help. It can help out. Okay. All right. Now schedule, I think TR 309, right? TR 309. You already have the same schedule as mine, right? So MA, MB, MC. It's from MA start from 6:25, and MC ended at around 9. But I think we can finish earlier. Okay, for today we can finish earlier, maybe 9 or maybe 8 something. So after this syllabus introduction, I will go just for chapter 1, early chapter 1, just to review what do you know about mathematics. Okay, great schedule. I think not a problem here. Okay, going forward, the because we will have the class 3-hour class every week. So yeah, this is for today syllabus, and we have groupings here, but I will just let you know the groupings later on. Okay. And then introductions for the chapter 1, for early chapter 1, and then continue next week, review numbers, and then move on to the functions. Now, the third week we move to polynomials, and notice that I write PBL. I will explain to you later what this PBL means. And then quiz. We move on to exponential, logarithmic functions, trigonometry. We have at least 2 trigonometry from the unit circle, right triangle, and then trigonometry for the equations, and then polar curves, parametric equation, and then another quiz. Okay, another quiz. Okay, another quiz. So whenever we have the quiz, we will have probably around 1 hour quiz, and then the rest of the class will be continue or reviewing the chapters, okay, for the next chapters. So after that, factors, system of linear equations, matrices, and you notice that this is also a PBL. Okay, later I will tell you what it is. And then still continuing matrix, system of inequality. But I think this can be done quickly, I think. So hopefully. So I think the last part here, we can make it faster, I think. Okay, so maybe in the middle of December we can have like either we will have final exam first, and then we will have a presentation, or we will have a presentations and then final exam. What kind of presentations? That is what I want to show you, and what I want to tell you with this PBL terms. Okay, so let me go to the PBL. So PBL, it's some educators describe the PBL as the project-based learning or problem-based learnings. Essentially same. And then what I want to do, what my plan is, I will look your total numbers first, okay? Because since you are for IATP students, you need to take this class, right? You need to take this class, all the students from IATP. So I think that we will have more students. So now participants is 34, but I'm not sure will this be the exact number, or there will be more. Okay, I think there will be more students. So we will divide groups. Okay, we will divide groups. If we have this 34, I think we will divide by 7 groups. No, I think 8 groups. 8 groups. So each will be 4 to 5. 4 to 5. Okay. What PBL? So PBL basically my role as a teacher or lecturer will be minimized. Okay, so you will be taking more roles. So for the class that has PBL mentioned, it means that you will get some notes or ideas before the class started, maybe a few days before it started, or maybe 1 week. Okay, 1 week or maybe 5 days before, 4 days before. I will upload in the Moodle, and then you will discuss with your groups what you want to do. Okay, you can present the topics. For example, let me go back here. For example, polynomials, or maybe this one, matrices, system of linear equations, matrices. So you can prepare some sort of topics, some sort of maybe applications, anything that you can think of. You can prepare, and then you can generate your ideas and present on the class. So in the class, you can present. You can present for sometimes, okay? Every groups will present, and hopefully, in a group, you need to give to your other member as well. So you will having some active presentations, and the other groups can also discuss. Okay, and that will be around 1.5 hour around the discussion and presentations. The last part, another 1.5 hour. This will be my part to maybe to confirm or to clarify some topics, and maybe to make some summary. Okay, so I need you to prepare this real well, because I think I can also make some scoring system or my grade based on our activity. Okay, so that will be the PBL class. Okay, now there is a last 2 weeks class that still has the PBL. This part, okay, this last 2 weeks here, the sequence, summation, arithmetic, geometric sequence. The topics may not be the same. Okay, I will update later on. Maybe in the middle of the semester, I will update what we will do for the last 2 weeks. Okay, so basically the last 2 weeks, as I mentioned, since we will have some topics that I think we can move really fast around here and around here. So polar parametric vectors, we can move really fast. So I believe there will be some weeks, maybe 1 or 2 weeks, that is not really having any agenda. So that week we will have some presentation, okay? Another presentations, and how the presentation will be. Basically, the presentations you will choose some topics. Okay, you can choose the topics from the textbook, or you can find out. This is the PBL class. Okay, we will just having two polynomials and the system of linear equations, as I mentioned before. The PBL presentations. This is the last two classes that I mentioned. It's not necessary to be the same as the sequence, like in the slide that I wrote. So the topics, it can be anything. It can be topics from the textbook, from my syllabus, or the topics can be from your interest. Okay, and the topics need to be related to math. Okay, need to be related to mathematics. And what I want you to do is basically, you just the presentation itself is not only presentation but also discussion. So whenever you find some topics, and you can elaborate the topics, and you can present it very well, and it maybe the other groups also want to discuss the topics, and you may have discussion. And this is my goals, okay? Because sometimes it's not so easy to make the discussion when you have like some sort of presentation. Okay? Usually, what the reality is, you having a presentation, and then after you present, and then that's it. But what I want is you have presentations, and then after that discussion, okay? And you have a question answers session, and then you have discussions, and then I can also add some points on the topics as well, okay? And so the presentations will also you need also to prepare the report one, okay? But I think just submit the presentations in the PPT. I think that's already fine with me. Okay, no need for a report. But if you want to add some points that are not presented in your slides, you can submit before the presentations. Okay, so before presentations, you need to submit the file, okay, the PPT file. Okay, so what needs to be presented? I need to select the topics. Okay, select the topics, and then you can also find any topic that you want to dig more. Okay, if you want to find, maybe you want to find, for example, the cryptocurrency, and you want to find what's the mathematical models behind it. It's okay. It's okay if you having that kind of interest, and then you want to discuss in the classroom. That's fine. Okay, that's fine. We can discuss. Or if you want to find out more about the like the image processing, it's also fine. Okay? But remember, since there are so many topics, and maybe there's many topics that really advance, you may need to discuss with me first, okay, before you present. Okay. And I hope the presentations, okay, you can elaborate the presentations in a simple way. Okay, so if you have like any advanced topics, so you can make it like more not really too complicated. Maybe just focusing on some parts, and then I think it's much more easier for you. If you take the topics maybe too many, or maybe too broad, it will be difficult to focus on, right? So that's the idea. Okay. I think I will give you more details, information on how to prepare these topics. Okay, maybe some procedure. Okay, and how to find. Maybe you need to read some articles, papers, and so on. And yeah, it's kind of you need to really read a lot of things, a lot of articles, readings, books. Okay, but I think this way, I hope you can have some a good or maybe good sense for study. Okay, for study, not only for study, but usually most of students, they think study is for exam. Okay, if I pass the course, blah blah. But what I want to build on my students is you need to study for yourself, not for passing the course. Okay? You want to try to understand what is really behind this topic. Why this is so important? Blah blah blah. Okay, so that's what my goal. Okay, but of course, the pragmatic perspective is okay. Study, passing the course, graduate from university, find a job, right? Very typical, right? But what I want to show you is you need to find your own motivations, why you need to do this, okay? Why you need to study, why you need to doing this, that, and so on in your life, okay? Not because your mom or dad telling you to do so, but this is because of you, okay? That I want you to make your own motivations. Okay, this is about the presentations. Or we can have some discussion if you want for today's about these the presentations. Okay. Okay, so the timeline for presentations, you need to find topics, submit the topics, and prepare for presentations. Okay. So you can have time. You have time to look for topics. Submit the topics first to me. If you have the same topics with the other groups, then if you can make like a focus, really focus on specific topics, even though the main topic is the same, but you have different focus, that's I think still okay. I think still okay. Like you want to make polynomials, but polynomials you can discuss in very different way. Okay? Like maybe you can discuss in more to application and discuss more about into like a classical problem, like retelling the story why people find the polynomials and why it's really useful. I think that's also a good way to start. That's I giving you like some simple idea, but I think you can elaborate more. Okay. Okay, find, submit, and prepare. Okay. Okay. I think this is the last in my slide. So after this, we will move to some introductions in the chapter 1. So I want you to, I don't know, maybe some sort of expectations that you want from this basic of math class. The advancement uh, for for this class compared with the calculus, this will be much more simpler, not really as advanced as calculus 1. So I want you to write anything. What's your expectations? Usually I write this to make sure that at the process, at the middle of the process, I know where the direction is. And remember most of the topics I already forgot. I know what you mean because basic of math is really foundations on math, right? Or calculus in our I think answer yourself speak for themselves. Okay. Okay, I just hope I can survive. Okay. Okay. Okay, let me prepare redemption from poor performance. Is it really hard? Is it really difficult? Okay, wait. I need to check. Oh. Okay. Okay, wait for a moment. I need to set up my settings first. Okay. Okay. Yeah, due to holiday, like 2.5 months. Okay. Okay, let me screen. Share again. Okay. Okay. Okay, you still see my screen, right? The expectations part, or no? Still? Okay. Check first. Okay, I think it's good. I want to enjoy math. Okay, I think in this basic math for studying. Okay. Enhanced math skill. Okay. Okay, let me also prepare my slides. Okay, maybe before we move on to another uh, introduction for class for the chapter 1, maybe I'm opening discussion. If you have any questions related to basic math or anything, you can ask. You can uh, write your questions in the chat box. Okay. If you have. Okay. There were many questions for a small amount of time and lack of practice during summer break. Okay, yeah, that's valid. Valid response. I think why you have like many questions for small amount of time is because um, I think it's a typical classic questions that uh, will my attendance be recorded? Yeah, yes. For the first class, attendance will not counted. Okay, no worry. Okay, no worry. So still okay. Okay, so back to Peter question response. Yeah, many questions for small amount of time is a typical a typical um, a typical method to to check the how well we understand the questions. Okay, so I think that's one kind of typical questions. Okay, okay, let me click there. Okay, okay, wait. I forgot to check. Any other questions you have while I'm preparing my lecture? Okay, any questions? Maybe I will just opening the the discussions. Like I'm not sure. For I think most of you are ITP students, right? I think only a few are not. Okay, I would like to know why you are choosing NTUST, particularly the College of Engineering. Okay, in ITP or any other engineering. I think why. Okay, that's I think a really valid questions. Why you are choosing engineering? Sounds cool. Okay. Any other any other idea? Okay, this is really funny. All right. Any other answer? Why you are choosing engineering program? Engineer. Okay. Yeah. Sometimes like in a typical family, it's like from your grandfather to your father, and then you, or maybe mother, and then you, and all engineering, genetically engineers. Yeah. Any other reason? I just want to know because you choose engineering, but I believe some of you in high school or maybe in junior high or maybe in elementary school, maybe in high school, usually like some of students they hate mathematics, but you want to be an engineer. That's really contradiction. It has a contradiction in my perspective. But I do know why you hate mathematics because of the curriculum and how they presented, how the mathematics presented. Isn't it presented as something that really related with you or your life? It's something that has some barrier. When you think of math, you think of numbers, you think of difficult equations to solve on, and you just think like solving problem, answer, finding solutions, and etc. But if you can relate your math, like you can model your life with math, and you can make some um, rare alphabet in mathematics. It's just difficult to understand. Okay. Yeah. I mean, why it's difficult to understand? That is the question. Should we turn on our cameras or not? It's up to you. If you want to talk and you want to unmute, that's okay. I enjoy complicated my life, therefore I guess studying engineering suits me. Okay, very funny. Okay. Uh, okay. Okay. It's just difficult to understand. Yeah. Yeah. So so you have your goal, at least goal for passing some courses, right? And then maybe later graduations. That's a particular goal for students. But for me also, I have a goal to teach you, not only giving you like giving you questions and then grade and then blah blah blah, but making you understand is one of my goal. And the understanding sometimes it is not the same thing as your score in your paper sheet. It's different. Maybe because our system, our curriculum, not really adequate or maybe not really fit for for all um, for all grading. Okay, so we cannot really comprehend all the um, all the students. Okay, that's I think one of the problem. But I think and I believe in the future we are going to evolve. We are going to evolve. I choose NTSC because I want to receive real and easy to understand. Okay. Okay, basically the learning method, and I believe being smart will give me a decent life. Okay. Yeah, that's one way to think. Yeah, one way to think. Okay, I think I will move to the lecture. So let me share my screen. Let me check whether it can be shared. I haven't tried this for a while, so it maybe it takes some times. Check. Oh, it works. Okay, it works. Right. Now, what I want to start with is if we think of mathematics. What is the building block? Building block of math. For example, let me give you descriptions what the question really is. I believe you start to learn physics, right? Let's learn physics. Physics is about matter, right? Matter. Let me write matter. So everything related to matter is physics, and we learn the phenomenon of the matter, the interaction with the other part of the environment, right? When we'll talk about the chemistry, it has a relation also with matter, which is matter has a structure, right? And the structure we usually call the small structure atoms, or maybe the electrons, or maybe the small one that I think humanity finds not so long ago, the high boson particles and quarks and etc. But we believe that there is a small structure, right? Small structure that makes matter. So we can distinguish what is the glass, what is rock, what is the plastic, what is the metals, right? So we can distinguish at least kinds of materials, right? Because we know the structure and how to build the structure, right? Now the question, what is the building block of mathematics? Any idea? What is the building block of mathematics? You can write. If you want, you can write in the chat box. Number, okay, arithmetic, any other, right? Number is a good, you have a good sense, okay? You have good sense for number. Any other? Logic, okay. Okay, any other idea? Quantity, okay, it's similar with numbers, right? Okay, good. Okay, have you ever thought this one? What is actually math is? Okay, if we think about numbers, we think about how to count, right? We start from, problem solving, probably okay for system logic. Isaac Newton being Isaac Newton. Okay, so we think of, let's say, a number. Okay, but number itself is just a number. Like we are counting the base numbers. We call the natural numbers, right? It is the numbers that we are seeing in our naked eyes, right? So we see maybe 4 apples, so we can count, there is 1, 2, 3, 4 apples, right? That's counting the numbers, right? We need more than the numbers. Okay, numbers is a good way to describe. So let me write here numbers. But if we say we have 1 plus 1. Okay, let me just start like from a silly idea. 1 plus 1. It became 2, right? It became 2. Why it became 2? And why it's true? It will be different if I say this is apple, this is orange. It's not 2, right? It is 1 apple, 1 orange. Do you get my point? So my point is, whenever we talk about mathematics, we are also talking about the rules. So we need to have some set of rules. So the set of rules is determine how the mathematics works. And the rule itself must be proven, at least proven. So that's why in math, usually you have some words like to explain what it is. Like, it's not just like giving a formula, you memorize the formula. It's not as easy as that. If you just memorize the formula, you will not understand the concept behind of math. Okay. So number 1, my tips: memorizations is useless if you are not understand. Okay. And sometimes you may forget, but you still understand. It's okay. It's okay. Some formula you forget, but you know how to derive the formula, and you know how to deal with them from the scratch. That means you understand. It's different. Okay. If you just know memorizations, then if you maybe change a little bit the problem, then you will not really understand. Okay. So the building blocks of math is not only numbers, but it's sets. Sets means you have a group of numbers that has particular rules. Okay. Since we already talked about numbers now, we begin with the natural numbers, right? The numbers that you are easily count in real life. You have 4 apples, 5 apples, 6 apples, you can count, right? So we are start with the natural number, the numbers that we can count in nature. Start with 1, 2, 3, 4, no problem at all, right? And then the mathematics world evolves, and we are having the integers. So integers is a natural number, natural plus the 0 and plus the negative. So for example, we start from okay. And then so that we also evolve, and we know that we have the rational numbers. Rational means that we are taking ratio of the integer. So let's say m over n. Okay. And we need to set some rules here, okay, to make it clear that n should not be 0. Because it will be a trouble if you try to define anything with 0. I will explain to you about that later. Okay, this will be a not really a heavy topic for today for this introduction, just to review a little bit what some numbers, and then um, a little bit of algebra that is really simple, just a little bit review. Okay. And hopefully we can finish. I think we can finish 8, 8:10 or 8:15 or 8:20 probably. We can finish very quickly. Okay, let's continue. Uh, so natural numbers, integers, rational numbers. Okay? And then we have the irrational numbers. Or maybe we start with the real numbers first. Or maybe irrational first, and then we can set the real numbers. Irrational numbers. So I will give you example what is irrational numbers. Okay, square root of 2 is irrational. Square root of 3 also irrational. Square root of 5 is irrational. Pi is irrational, and there will be another number as well. E also irrational. What is E? Well, we will have that in later explanations. But what this irrational numbers means is they can't be expressed as a ratio of integers. So if you try to find out the rational for example, you know that the 0.5 you can express as 1 over 2, right? Now these numbers here, they will have their decimals, but you cannot make it into the rational one because the decimals usually really long. That's the irrational. So that's why it's called. It has the I, irrational. So it cannot make its rational form. Okay, so that's the way to understand the words. And we say the numbers that has all the numbers from the natural, integers, rational, irrational, we call the real numbers. So we can write maybe 1, 2, 3, blah blah blah. This is, we call the natural numbers, right? Maybe let me write in red. Natural numbers, and then let me take this. Okay, and then if you have 0, this will be integers. Let me erase this part. Okay. And then there are half, okay, this is the random rational. Let me move this a little bit down here. This is, we call the rational numbers. It's also include all in this world here. And the other part is the irrational. It's outside of the rational. We can write square root of 3, square root of 5, pi. Okay. Okay. Now the whole thing here, rational and irrational, including the integers and the natural numbers, we call the real numbers. Okay. If you say that they are real, there will be another set that is not real, which is imaginary, but we will discuss that part a little bit later on. So this is a real number. Usually we are using the symbols R, okay, like this, having this kind of symbol for the real numbers. Okay, and for as your preference, for a preference, for the irrational one, I forgot to mention that since, for example, the pi, it has many decimals, right? 1, 4, 1, 5, 9, 2, blah, 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 right? So you still you have this dot because it has many, many numbers. If you want to cut the numbers, you can do as well, but you will have the approximation symbols. For example, you can cut this until 5, but you will have this approximation, okay? Because this is not pi. It's approximate to pi, okay? Just to some additional information. Okay, this is real numbers. Okay. Now the next section, we will have some quick review on the properties, and I believe you already familiar with these properties. Okay. So properties of real numbers. First is commutative properties. So a plus b is b plus a, right? And then a multiplied with b multiplied with a. I think you are familiar with this. So I will quickly just write and review. Okay. And associative properties. Maybe it's not clear. Let me just rewrite this. Associative means if we add these three numbers, it's the same thing when you add the other one first. For example, we change the brackets. Or if you multiply, same thing if you multiply. Okay, associative. Well, the name is not important, commutative, associative, but if you know how, I think it's okay, it's fine. And then distributive. I think learned this at elementary school, right? Means that you can distribute this A to B and C, so AB plus AC. Or if you write B plus C first and A, we could have the same result as well. Okay. Just a quick review. Okay, let me just continue. To the addition and subtraction. Really easy, and my goal is just finishing all today. Okay. Addition and subtraction. Okay. Before we move to the next one, in the addition and subtractions, you will notice that the number 0, we call this in officially, but you don't need to memorize it. Okay, you don't need to memorize it. 0 is, we call the additive identity. Why? Every time you hear the word identity, either in any topics in math, usually it means is whenever you add 0 with any numbers, it will be the number itself. For example, 2 plus 0 is 2, right? It's, well, you know that you already learned this before, right? So any numbers will be the number itself. So that's why we call the number 0 is the additive identity, because if we add, it will be the same number. And then every number will be having their negatives. For example, every real number a has a negative a, okay? And this negative a will satisfy that when we plus these two, it will result in 0. Okay. This is very, very fundamental. Very fundamental. You already know how to deal with the practical process, right? The numbers itself, but this is actually what it really means. Okay, so the one that found 0, like before, humanity or mankind confused on 0 because maybe they haven't found it yet how to write the 0, but when they found it yet the 0, it's the math becomes more useful, and then they can count the negative, right? And then they can make financials, right? They can write their financial reports and so on and so forth. Okay? And then from the negative, we have the property of the negatives. Okay, so -1 multiplied with a becomes -a. And then negative a has become a positive a. Okay, and then -a multiplied with some number b, it's the same thing as a multiplied with -b, and this is the same thing as -ab. And if you have the -a and multiply with -b, this will be a positive ab. Okay? If you have a negative a plus b, then you can distribute, and you can distribute becomes -a, -b. Let me make it clear. And then negative a, -b, this will be -a. Okay, I hope this is very easy in practice, but it's really fundamental. Okay, I don't think I need to give you some examples. I think this is quite simple and easy, right? Okay, so this is for um, additions and subtraction. Okay, the idea of subtraction is actually additions, but having the property of negative. Right? So actually, when you subtract, actually you are adding something, but adding with a negative. Okay, that's the definition. Okay. Okay, I will move very quickly here. Okay, now it's multiplication and division. Okay, for multiplications, we can see that 1 is a special number. We call this is the multiplicative identity. Okay, again, we have identity. It means that if we doing something this one, we multiply. The number is just its number. Okay, so if you have a number a multiply with 1, the result is just a. Okay, so that's why 1 is its identity. And then every non-zero real number, okay, a, so a is not 0, it will be having an inverse. Let me write inverse as an inverse 1 over a. That satisfy a multiplied with 1 over a is equal 1. Okay, and division basically operation that undoes the multiplication. Okay, so by definition, a divided by b is basically a multiplied with 1 over b. Or simply we can write a over b. And we call this sometimes in mathematics, we call this the quotient. The quotient of a and b, or a fraction a over b. I hope you already know the terms, okay? And we call this a over b, okay? This is we call the numerator. This is we call the denominator. Okay? We can also see some properties of the fractions. So a over b multiplies c over d, ac over bd. And then a over b divide with c over d. This means that we will have a over b multiply with D over C. Okay? And then A over C plus B over C. So the same denominator, so we can just combine these two. And then A over B plus C over D. Then we need to make BD AD plus BC. And then AC over BC. It's A over B. We can cancel the C. And the last one, I think I need to have some space. Okay. So if A over B is C over D, then AD equal BC. Okay, I think it's quite intuitively you already know. Okay, intuitively you already know, right? Okay. Another way to think multiplication and division is by looking at if we have multiplication. If we say 2 multiplied with 1, we know that it's 2, right? But what it really means is we are having 1 and then plus 1, right? And we can have, if we have 2 by 2, it means that we have 2 plus 2. So we can have some set of, so multiplication is some set of additions in order, right? Addition order. Or if we have 5 by 3, we know it's 15, but it's what it really means is 5 plus 5 plus 5. It's 3 times, right? 3 times, 2 times, 2 times, right? And we simply look at 5 and 3. So 3 means how many times? Or we can write 3, 3, 3, 3, 3. This is 5 times. Okay. Well, divisions, then it's not addition, it's subtraction. We can also think as a subtraction. So when we divide 15, divide by 5, means that we will have 15 minus 5 minus 5 minus 5. It's become 0, right? It's become 0. But how many times we subtract? 1, 2, 3 times. So that's why the answer is 3. Okay. Now, the trouble, like I showed you before in the rational forms, is when we divide something by 0. The idea of the division is as like a subtraction. Like, for example, if we divide 15 by 3, we will have 15 minus 3 becomes 12, minus 3 becomes 9, minus 3 becomes 6, minus 3 becomes 3, and minus 3, and it becomes 0. So when we reach 0, then we successfully divide our numbers, right? So how many times we have? 1, 2, 3, 4, 5. 5 times. And it's true, right? It's 5. The answer is 5. When we divide by 0, 15 minus 0, minus 0, minus 0, blah, blah, blah. Can it be 0? It cannot reach 0, right? Can't reach 0. That's why when we have this, we call this undefined. Okay, just some additional information. Okay. Okay, a little bit more. I think 8:30 will be. If you want to like stop, maybe going to previous slide. If you want to write, let me know. Okay. If you will just keep silent and then maybe a week later you asking blah 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 why this and that, please in the class, please be more active. Like if you want maybe to write some notes, maybe you can tell me, Prof, wait for a moment, I need to write this. Just tell me, okay? Because sometimes I will move to the next slide, okay? Or if I teach too fast, please mention also, okay? Okay, I will move to the next slide, go to the next page, okay? Okay, another concept that's really fundamental in analysis for especially in later in calculus, okay, in the basic math to learn the numbers is the line numbers, okay, the line numbers, or let me just write the real numbers, okay, the real for the real numbers, so real line. So we can represent our numbers, our real numbers, in some sort of line. Let me check my where is my, is this, okay. This is just an example. So real numbers, for example, if we see, okay, if we focus, maybe you can focus first on the integers, okay, the integers. So -5, -4, 0, 1, 2, 3, and etc. Okay. The other numbers is just for your reference, For example, where is pi? So pi is around 3. So, oh, here it is. It's pi here. And another other numbers as well, like the rational, irrational. You can see how they build up in this line. Okay. So how do we use this line numbers? Okay. So we are usually just using the integers. Okay, using the integers. This is just for reference. So for example, we create our integers. Let's say from -4, -3, -2, -1. Okay, just reference here. So the line numbers is useful if we want to observe, okay, to observe the value, okay, the value. So if we say, okay, that, let me say, if a is less Let me write first in the words. It's less than B. We write A less than B. We can write this if B minus A is positive number. Right? Geometrically, what this words means, this last means, or this terms means that A is on the left, right? A lies on the left of B. Okay. Same thing if you write B greater than A, then that means B is left in the left or A is on the right. And we may have also the greater equal symbols means that it may have the same value. Okay, it may have the same value. So it reads A is less than or equal, or less equal is also okay to B. So 7 less than 7.5 less than 7.8 less than 8, blah blah blah. Okay. We need to deal with this common sense in math. Okay. And since we know the real numbers, then we need to, for example, if we have the square root of 2, means that it's going to be in between 1 and 2, right? Because later, when you advance into calculus, you need to have some logic in how to analyze the numbers from the equations, blah blah blah. Okay. So when you deal with how to write, maybe how to make sure that this is true, that this is in between these numbers, you need to have a good sense. Okay, good sense. And if we say negative pi, then we need to say that pi is 3.1, so it should be less than negative 3, right? And so on and so forth. Okay. That's the real line. Okay. Okay. Another thing is the sets and intervals. The sets and intervals. Again, sets, okay, is a collection of objects. And this object is called the elements. The elements of sets. Usually we just say with the symbol letter, with a letter. So if S is a set, then a element of S, it means that this means A is an element of S. Okay, A can be any number. And we say B is having that symbols. It's not an element. Okay, it's not an element. So this means that B is not an element of S. Okay. For example, the integers, these integers, okay, represent set of integers. Okay. In integers, we know that -3, this will be an element in the integers. But pi is irrational, so it's not an element of integers. Okay. It's a quick review. Okay, let me just give you if. Okay, if I define a, if a is set of numbers from 1, 2, 3, 4, 5, 6, okay, and then n of 6. We could write this in a notation. Usually we write using some variable to help to write here. A is any x, which means any number that vary from 1 to 6. X, as x is an integer, and between this interval. And then, of course, from the definition, since it's integer and it's from 0 less than x less than 7, which means that this is another way to write this 1, 2, 3 to x to 6, and we can write this. Okay. This is A is the set of all x such that x is an integer and having interval 0 less than x less than 7. Okay. Okay, now we are slowly building our building blocks on mathematics. Okay, we're slowly creating our foundations. Okay. Okay, so we learn about sets. Now, if we have more than one set, we can have some relations between them. We can have some interaction between them. So I think we need to. Let me just write here. Make a little bit higher. Okay. Okay, if S and T, they both are sets, and then we call union S, and then like the letter U, but it's not a letter, but similar to U. We call this is the union symbols. So S union T is, let me write here. This is the sets. This is set that consists of all elements that are in S or T, or we can say it's both of them. Okay. So first is the union. The second one is the intersections. So intersection, we can write the symbols upwards from the union. Okay. This means the set consisting of all elements in both S and T. Or to make it different, or to make distinguish, we can also say that S intersection T is the common part of S and T. Okay, so it means that which elements from S and T that are the same, that is the intersection. Okay, I think I can make it in a real easy way with a picture. So if we have S, this is S, and this is T. This one here is the intersections, right? And all of them are the union. Okay, I think it's better to draw like this. It's easy to understand. And there are also a symbol with this kind of symbol. We call this an empty set, which means that this is no element inside. Okay, let me just give you an example. If you have S, 1, 2, 3, 4, 5, and you have T, 4, 5, 6, 7, you have V, 6, 7, 8. So if we have S, U, T, it means that we will combine these two, right? So 1, 2, 3, 4, 5, 6, 7. And then the intersection, S and T. What is the intersection? We'll see that this is having 4, 5, 4, 5, the same element. So we are having this 4 and 5 as our intersection. And if we have intersection S and Phi, we don't have common numbers, right? So we can say this is an empty set. Okay. Okay. That's the union and intersections. Okay. Okay. Let me go back to the line numbers. Okay. Let me go back to the line numbers. So we call this is the sets and intervals, right? So the intervals, if we have the line number like this, let's say we have A and B in between these line numbers. If we have A like this, we have this interval. Okay. We call this circle here, we call them the open interval. Okay, the open interval. This is also open interval. If we have like this is closed interval. And we can have a combination in one line number. Maybe this is open. So this is open. Or we can have both open, both closed, one open, one closed. We can have that as well. Let me just give you a brief description here. Or maybe let me just take this a little bit left here and this a little bit right here. And let me put the descriptions. Okay, this is one way to describe. Okay, so we can have notations like the left part here. So AB, and we say we have the brackets here like this. This brackets means it's an open interval on A and B. Okay, I hope everyone can understand that part, because it's just a really simple method, but in calculus, if you wrongly describe or wrongly write the description or the bracket, you wrote the wrong type of bracket. You're wrong. That's the so you need to be careful, okay, to see the difference. Okay. The next one is having this type of bracket here. Okay, this bracket is for the closed interval. So close means that you need to include the number. Okay, you need to include the number. When you have the open, you are not including this number. It is not included. Okay, I hope that's very clear. Okay, I hope it's clear. So if you having equal means that examples. Okay, examples. I think examples maybe next week we can have review. Okay, I will go through all the details, and I think exercise maybe later on. Okay. So you can describe also in the line numbers with this circle. So we have full red circle, and it means that it's closed. Okay. And we have a combination of those, both of them. We can have close and open, open and close. Okay. So this is the first four types. Okay. And then we may have another symbols that I introduced today. I think you already know also. This is infinite symbols. Symbols for infinity. It means that it will go through all the way to the, if you look on the line number, it will go through all the way to the right without any stop. So it's not describing any stops, right? If you see this B here, it stop here, right? It stop here, it stop here. Okay, it has some restrictions. But if we look at the infinite symbols, it goes through all the way. Okay. But we cannot really comprehend how high or how big the number is because it's infinite. Okay. And in a short summary, the infinite is not a number. Okay, it's not an exact number. Okay? It's not an exact number. It's an abstract number that gives you a sense that it's really, really huge. Okay, I hope you understand that. Okay, I think in some section in either in basic of math or in calculus, I will explain more about this infinite symbols. Okay. Okay, and then same thing. We have the closed interval, and in the notations we can just say that A is less than or equal with some x. So this x can be any numbers. That's why we need to have like infinite here, because it can be any positive numbers, right? Any positive numbers. Okay, same way, if you look from the left side of your line, okay, from the left side, means that you will have some also infinite numbers, but in negative. So we can write this negative in negative with infinite symbol. Okay, so we can write like this, and then we can write some x less than b. So B is our restriction on the right, because we can move to the left without any restrictions to the left. Right? We can have like negatively large numbers. Okay? And if we have this is a common way to write the interval. That is, they are all in all possible numbers in the real numbers. Okay? So set of all real numbers. So we can just write this R, okay, to describe this interval from the really negatively large to positively large. Okay, to the from the most left to the most right. Okay? The farthest left and the right. Okay? So we just draw the line numbers, and then we can see that it's going from really left to the really left. But for me, the line numbers here become meaningless. It's become meaningless because not really useful. We can just write this as R. Okay. Okay, that's the interval. Okay, I think because you mentioned the examples, I think we can give you examples, okay, to utilize this the interval. Okay, let me give you in the next page. Okay, maybe make it a little bit bigger. Okay. Okay. Yeah, maybe after some examples, I think uh, we can stop. Okay. Okay. Some examples. Okay. The questions is graphing the interval. Okay. So let me just give you interval. I think this is quite easy. So the notations first. Notations 1, 2. So from interval from 1 to 2. So we can write the notations x, as x is a set from -1. Remember the brackets? It's less equal, right? Less equal, because it's a closed bracket. X, and then less, it's open bracket, 2. And then the line numbers, we could, let's say this 0 here, so -1 is here, 2 is here. But I think if you just write as the numbers, as long as you write with the correct order, I think it's just okay. So -1 is closed, so close, and 2 is open, so open like that. Okay, that's the line number. Okay. I think very easy, right? This is 1.5, 1.5. So x, as x is between 1.5, both are close, so we can just write quickly here. So let's say this is 0, this is 4, and maybe 1.5 is around here. And then it's both are close, so we are just taking this circle and then write like that. And last one, this is x as -4 is less than x. Okay. This is 0, maybe -3 is here, And we will have like this line here. And this is all open interval, so forget the right. Okay. Okay, I think it's not too difficult. Okay, however, if we try to include the union and the intersections, can we still doing the same? Let me just give you more challenge, okay, with another example. So do the same thing with this. First is interval 1, 3, both are open. Intersections with the close interval 2 and 7. And then the other one is, and then union. Okay, same numbers, but one is intersection, one is union. Okay. First, if you maybe need some time to process, then let's just try process one by one. Okay. So first, we say this intersection. Let's just write the notation for each interval. So first is for the 1 and 3. Okay. And we can just write with and like this. This is also fine if you want to write the notation. And 2 less equal x less equal 7. Okay. Now from these definitions, we can also wrap these notations become the intersection. So we have 1, 2, 3. So 1, 2, 3, we can exclude 1, but the 3, or in between these two, in between this 1 and 3, we can have 2, right? So 2 is also here. And also 3 is inside here. So 2, 3 is inside here. So the set of interval that we can write is x. Okay. 2 is less equal, as it mentioned in here, but the restriction on the right will be 3, but it's not included, so we can say it like that. So we can say that this will be included, or we can write notations. Or if you want to write in the notations, in the line numbers, I mean, first we can write, I think too long, I think just right here. I think first we could write, let's say 0 is here to make it the same. 1 is here. 3 is around here. So first 1 to 3 we can write the open interval, or maybe with red color. Open interval. Okay, this is 1, 3. And this will be 2 to 7, maybe around here. Both are close, so we can write, and then we can write like that. Okay. This also refresh your memory how to write the line numbers, right? I hope you still remember how to do that. Okay. And then the results. If you see the results, these 2 and 3 will be the intersections, right? This is the intersection. That's why we can have this 2 and 3 as our results. We include 2 but not include 3, so we can have open interval here. Okay, so I hope you can see that when you draw the line, visually you can see the intersections, right? You can see the intersections directly, right? On the other hand, for the union part, this will be, if you want to write directly the notations, you can write x as x is between 1 and 3, or okay, 2 less than x or equal x 7, sorry, and then less equal 7. Or we can say that we can combine these two, becomes 1 less than x less than or equal 7. Or we can write 1 to 7, not include 1 but include 7. Now we can prove this with line numbers. So visually we can have some proof. Okay. So this is 0, 0, 0. This is 1. This is 3. So let me draw open interval, open interval. Okay. And this is 2. Maybe 7 is around here. And include both. So in union, you need to just looking at the left side here and the right side here, which is 1 and 7. So that's practically our answer. So we will have from 1 to 7. Not include 1, but so it's open, but include 7. Okay. I hope this is clear to see the proof for what we have in the notation for visual proof what is really going on. Okay. Okay. I think I need some more times. Okay. Not really 8:30. Just one more section. Okay. Just one more section. It's about the absolute value and the distance. And then we finish the early part of chapter 1. Okay. Maybe any questions first? I hope you still can catch up, okay? Because it's really, really, we haven't yet touched the difficult part. Okay. If you have any questions, you can write in the chat box. Okay. Yeah, you can take the screenshot, but which part you want to take? This whole thing, or maybe here, right? Maybe this. Yeah, I think this one, I think it's okay for screenshot. I hope it's clear. Okay, I hope it's clear. Okay, the first part of our introduction is just to show you how the mathematics works and how to write the notations, the line numbers, okay, the intervals. Okay, that's the important thing. So the numbers, stats, intervals, they are all the building blocks. Okay. Okay, I think I will just move to the next page. Okay. So the next one is the absolute value and distance. So definition of absolute value. So by definitions, okay, absolute value is like a distance. Okay, distance is always positive, right? So let's say if we take the line number, if we take the -3, this is 0, this is 5, okay? If we walk through these line numbers, okay, we know that from 0 to 5, we need to move 5 units, right? So we can say the distance is 5, right? The distance is 5. Or in the symbols, we can write with this symbol, which means that this is the distance of 5. Okay. Now, from -3 to 0, when we walk through from -3 to 0, we walk 3 units. We know the distance is 3. Okay. That's why we can write also with this symbol, and we say that this is 3. So basically, what absolute value means is it's a distance, actually a distance from some A to 0, okay, on real number line. Okay, so distance is always positive or 0. So we may have this property for every number A. And by these definitions, we can break down. So if A is real number, then absolute value of A is so the idea behind this is to show that whatever A you are getting in, the absolute will be positive. Okay, so it can be a positive A or negative A. So this will be positive A if A is greater or equal 0, or if this is negative, then A is negative or less than 0. Okay, some property. Okay, some property. As I mentioned, this absolute value of A is always positive. Okay, and then we can also say this is the same. Okay, the same thing.
I didn't get that. Could you try again?
And then we can separate this, become each absolute value of A and B. And then this will be the fraction. We can take this separately. Okay.
Okay, I found this on the web and then we can separate this, become its absolute value of A and D, and then these fractions. Take this. Check it out.
Okay, this is the last one. Okay. Now this is we call also the triangle inequality. Okay. Now another property, because we define the absolute value as a distance, then let me write this all on the left side here. Properties. We can also write the distance between points on real line numbers, or a real line, it's okay. So if A and B real numbers, then distance between A and B on a real line is, we usually use the symbols D for this distance, D. So if you write DAB like this, it means that this is the distance from A to B, okay? And this is, we can write absolute value, B minus A, the definitions. But we can also write A minus B because it doesn't really matter, okay? Because it's actually the same thing, okay? When you look on the property. So this is also the same thing, okay? I think that's all for today's class. We end on this real number. So basically, the first introduction here, aside from syllabus at the beginning, is introduce you to the fundamentals of numbers, okay? Sets, intervals, real numbers, okay, and as a whole. And the next sessions we'll move on to some. We go to the exponent, radicals, algebra, rational expressions, equations, and then complex numbers. Okay? And then after that, we will move to the next chapter, which is the functions. Okay? So next week we will discuss exponent, radicals, algebra, rationals. Okay, I hope we can finish that with the introduction of functions. Okay, I think that will be our goal. Okay. So any questions? Any questions for today's class? Since it's recorded, I will upload later and share the link through the Moodle system. Okay. Okay. Any questions? If not, then this will be the end of our lecture for today. Okay, for today's class. Okay. So next week we will continue. Okay, continue from these fundamentals and then move on to functions, and maybe that will be a little bit more difficult than the first one here. Okay. Okay, if you have any questions, please you can ask. Okay. If you didn't have any questions, you can leave the meeting. Okay, you can leave the meeting, and see you next week. Okay, and next week we will be in the classroom. Okay. Okay. Goodbye, everyone. Yeah. Good night. It's nighttime already, right?